Good morning, this is David Johnson, and today I'd like to review the Project Sizing Form interface. But before I start, I'd like to say that thus far, at least from my experience, Hypersizer is kind of a P over A analysis package in a software box. In other words, it's one of the few packages that actually does our detailed analysis pretty much in the way we do our old hand cranks back in the old days that very few people are capable of doing. So, I'd like to give it compliments in the fact that I haven't found anything that I can optimize, say, a wing skin stiffened structure or any type of primary structure in such a short time with great accuracy, and probably get within 10% of the final solution within a very short time. I think probably the biggest issue for me is we have a huge amount of features. I could actually probably do 200 Hypersizer lessons and not get close to covering all the topics. So we have a huge capability, but this interface only really shows, at least at first sight, shows a very small amount of the capability. And what I'd like to do is just go over this interface and just make some suggestions as to where things slow us down. I think I have to do a lot of checks and balance, and I find that it's very difficult to do it without opening up stress reports and looking at the stress methods documents. And I shouldn't really have to do that. I really want to see the parameters, I want to see the strains, I want to see all the details of the A's and B's and what assumptions were made, and unfortunately you can only see that if you go look at the stress report and you go look at the methods document. So starting with a dimensions document, dimensions tab, I kind of like this interface. This is one of the interfaces that I do like. It's simple, it's straightforward, it's very easy to understand. I get it. I can freeze my design here. I can see what the concepts that Hypersizer comes up with. I can say how many designs I want. I can see the number of candidates. I can easily copy this box to some of my other components. It's very easy to use. So my only real comment on this particular screen is that sometimes I found when I'm optimizing, these steps are not very practical. Sometimes I don't want an equal step. Sometimes I need to look at, say, 3 or 4 different designs and they're not equal steps. And so I have to compromise, at least to start off with, to get approximate, and then perhaps later on dial in a smaller step and get the steps that I want. So it would be good here to have an option just to put in the actual values I want. For instance, I might want 30 thou, I might want 36 thou, and I might want 53 thou for some strange reason. Obviously a minor point, we can get around this, so that's not really a big deal. Now going to the failure tab, this is a lot better than it used to be, because now we can sort by the lowest margin of safety or the controlling load case. Back in the old days, it used to only sort by load case. We can sort margins and we can hide the unselected. And we've got lots of options here to copy all of our analysis methods to other components. But just giving an example here, I'm doing some composite analysis. A lot of people use ply analysis, even though I really prefer laminate analysis, but most corporations use this ply by ply, which I think is kind of wrong because we have damage requirements, and I don't quite know how you figure out damage on a ply by ply basis. I think it's fundamentally flawed, but it is what it is, and it's what we do. And most of the smart companies, they use the max strain theory. These other ones, once you start to do the testing and you start to correlate the test data with the theory and you do it biaxially, it starts to get very complicated, and there's a lot of hidden problems with using these. And after all this time, many years, I've come to the conclusion max strain is the way to go. And a lot of the smart companies use the max strain theory for doing their failure analysis. Now the issue is that every time I pull this interface up, I have to stare at all of these and kind of struggle and look around and find what I want. And really what we need, in my view, is to go to the analysis defaults, analysis methods. What we need here is another button. All of these methods need another button. And let's say I'm the stress manager of the whole place and only the administrator can change these, but the administrator can come in and say, my company doesn't use any of these methods. In fact, it only uses one, because, well, maybe two. Perhaps I only want two of these. But if we go down to the composite analysis, which is this one, you know, I will never use all of these. If I could work at a company for 20 years and all I'm going to use is max strain 1, 2 and 1, 2, and that's it. Never going to use stress, never going to use SIWU, never going to use any of these methods. So why do I want my stress engineers to have to go and stare at all these methods? So what we need is another little box, so I can just say I only want to see these ones. And then when I come to this interface, all I see is top face, max strain 1, max strain 2, max strain 1, 2, and bottom face, max strain 1, max strain 2, max strain 1, 2. Now all of my stress engineers, even the ones that don't really understand composites much, they can go, okay, this is what I've got to choose. And it becomes very straightforward. The other thing that I'd like to have, which is very big and probably would take a long time, but if I right click on here, I can go look at the methods documentation and I can review the analysis, assuming that you've got some companies you can't see it. I think you have to have special privilege, I'm not sure, but I've noticed that sometimes I can see it and sometimes I can't. But assuming that I can, but what I really want here is to say, you know what, this is a minimum margin. I want to click on here, and what I'd like is a window that opens up, and all of the parameters that are included to do this calculation, everything, the margins of safety, the factors, whatever it might be, all of the strains per ply, I want it to come up so I can actually see what really happened, so I can see if I've made a mistake, or see if I've missed something, or I've got a wrong factor. I mean, right now, if you do strain analysis, I mean, really you don't have anywhere to go. I mean, you have some loads and you have some stresses. And so I don't really know what the strain is. I have to go make the stress report. So I think that's one of the biggest shortcomings of Hypersizer for composites, is that I really want to see my strains, both in 1, 2 and 1, 2. I want to see the 3 strains for my shell elements for each ply. Well, actually they're all the same strain, but anyway, but I still want to see the strains. If we move to the free body tab, there's some good in this. You know, we have the FAA loads and we have the user loads. Notice that when I put the user loads in, I can put a pressure in. If you have FAA loads, unfortunately, you can't add pressure to your analysis. So there's one restriction. But my major comments here are, when I put on a pressure, and I put panel pressure here, and all these other options, zero out, FAA moments, initial perfection, beam column. If we consider there's 100, let's say there's 100 analysis methods in here, P over A, and there's maybe, just for example, I'll just say there's 10 methods that use these parameters within the analysis methods within Hypersizer. I'm never really sure which of these, I mean, obviously I've got a pretty good clue, but especially for a new user who's going to say, well, when I put this 0.003 in, what analysis method does it relate to? You know, actually I know it's a compressive beam with an offset. So I would prefer, for clarity, for the interface to be redesigned, and obviously this comes back to my requesting almost a screen for each of the analysis methods, so I can see which parameters are used for which analysis, just to provide a bit more clarity without having to dig around. Because even when I do use this software a lot, I still have to dig around in the stress reports a lot to just check what parameters we use for each analysis and just make sure that I fully agree with, or at least I've made the right clicks and I've got the right answer. I'm not sure whether we need this here. Maybe we do. I guess that's kind of arbitrary. And then we got this free body diagram. And as you can see, I've actually run this. I don't have anything in here. I never used this actually. I probably should understand it better. I probably did in the past. But probably one of the better features of this program is that I can manually put in these loads. So this is something I do like. This is definitely something required, because I may not want to rerun the FEM. I may want to, for some of my components, just put in some hand loads just for now to arbitrarily change the loads. But there's some things here that kind of bother me, especially this panel pressure. When we put pressure on here, in reality this plate doesn't bend. It's in membrane for most aerospace structures because it's too thin. If the displacement's bigger than the thickness, it's a membrane structure, so it's pulling on this stiffener, but it's also adding a bending moment to this stiffener, and depending on whether we put simple supports or fixed here, or even simple supports along here, it makes a difference. And I only have part of the solution here. I'm pressing something, but I don't really know what I'm going to get. So I just think there could be a lot more clarity here. Moving on to the FAA Loads. Without going into too much detail, just keeping it basic, these always bother me. These factors here don't seem to coincide with the other form where we put the main factors. We've got to combine them somehow. Maybe, I'm not sure if Craig changed this, but there's always been an issue with understanding what factors I've really got. These factors are just for the component only, whereas the other factors, ultimate limit factors, are for the whole structure. But I can combine the factors. For instance, if I've got a 0.66 factor on limit in the other form, that doesn't show up here. It's confusing, and we've got the wrong answer a few times because of a few people don't really understand what this is. So these are the mechanical ultimate just for the component, and we have the limit and ultimate factors for the global on another sheet. But at some point we combine them both. And if I got this wrong, I guess Craig can tell me. These are really good, thermal hurt and thermal help. You have to understand that. There's too much detail here. I've never used these KTs. I've never used this for fatigue, so I can't really comment on that. But one thing that I do think, just talking very generally, I can't get into all the details of all of this stuff, but just generally, whatever option I click on here, and I haven't got it, it's not highlighted because I need to rerun it. But whatever option I've got here, if I do element based or statistical, really, let's say I do element based, I don't want to see all this stuff. Whatever I click here, the option I pick should actually determine what shows up in this screen. I don't want to see all this stuff all the time. To me, it's just confusing. So I don't have a T-peak and a deviation. If I pick element based, hey, I've got a max element load in that component, and hopefully that maximum element load that's the design driver for that particular piece of sheet, the highest stress, will show up as loads here, and that's really all I need to know. Again, these pressures and temperatures, these kind of go with my comments on the last. I've got to understand where these go and what analysis methods work. So I have to separate separate out, or even if there's some help comments here to say, hey, you know, you label all analysis methods are all labeled, they all have an ID number, and say, hey, this pressure is applicable to analysis 56. I think it would help a lot. And we have different NXs here for strength and buckling. I guess that's okay. I've never actually used different loads. If I've got a strength analysis, I usually have the same buckling load for the strength. Both have the same criteria, but maybe I'm missing something, other people have different requirements. Stress. Well, what's ironic really is these aren't stresses. These are loads. So maybe I think these should go in free body, but I don't know. I mean, this is what we use in a free body. The standard stress gauge back in the old days only used Patran to go and find these internal loads. Patran was a loads tool. Patran's never been a stress tool. And what we had to go and find is our NX, NY, and NXY, then go do our analysis. So these are loads, they're not stresses. So I'm not sure why they belong here. These stresses obviously are useful. It always intrigues me why I need all these decimal places. I've talked to Phil about that 3 or 4 times, but there's some programming issue there. But I never like, if I did this 20, 30 years ago and put all these decimal places, some of my chief stress engineers would have fired me. Now it's, you know, we don't have those people around anymore. You see guys write 12 significant figures as if his analysis is it's not even close to 1% being accurate. Because within 10% he's lucky. So really only the first 2 significant figures are of consequence, maybe the third if you're really lucky, but I don't need to see all these numbers. So it just looks messy. It's kind of hard to read. It's difficult. It's like looking at computer output. So I'm a big proponent of just being clean. It's pounds, and I don't care whether it's 0.79 of a pound. I'm a stress engineer. I round it up to the nearest pound. Good enough for me. 6075. That's good enough. That's all I need. Never going to use these decimal places. So, but I think that one of the things about the composite analysis, we don't have the strain. So, to me, is we need a stress and a strain tab, or you combine the two. I don't know what we do. Maybe we need a composite output tab with the strains for each of the plies. I'm not sure, but one of the most important things that I need is not here when I'm doing composite analysis. I want to see my strains. I want to see strain 1, strain 2, and strain 3, and I want to see the allowables in each of the 3 directions. I'm using max strain theory, the margin simply, the allowable strain in that direction. I'll get this the right way. Yeah, the allowable over the applied, -1. So, you know, that's good. This temperature, I think when we do the allowables, I think there should be more explanation of, well, this is what I'm calculating my allowables on. You know, I think it just needs a lot more something I can't really explain. But anyway, same thing for here. We're saying I'm going to apply the local pressure. I'm not sure why we have the button on here, and it's also on one of the other sheets. So I guess when you click on here, it turns it on the other sheet too. Then buckling, this is quite a nice sheet. This is, as always, we want to keep it simple. We don't want to make things look too complicated and confuse people. If we make it too complicated and confuse people, I always feel as a stress guy, we haven't done our job. And most of the real pros from 20, 30 years ago, they were really good at just doing P over A and NY over I and doing some simple calcs and free body diagrams, and it was all cool and all looked good. Now I get 100 pages of computer output and a lot of, you know, just too much detail. I can't even figure out what's going on. So I think this is a really good sheet. It's very simple. I just say what my boundary conditions are. It's very clear which is the X and Y. Very important. That's why you understand which is the X direction for the plate, because if you get them the wrong way around, you're going to put the boundary conditions wrong. So that's why it's very important to check that when you're importing your model. You can see here we can have curved beams. I like that. It's good. You can have a full cylinder. It explains here the Z.
There's some issues with this Z. I'm not going to go into it here, but maybe it's a separate issue. Unfortunately for composites, this Z is the wrong way around. Or maybe I will mention it now. We all know that the tooling surface is the reference plane for composites, and Z is always away from the tooling surface, not into the tooling surface. Hypersizer has been set up to have Z outboard, and the stiffeners are on the opposite direction. Well, it was really unfortunate, but that's the wrong way around. And so I'm not sure what the workaround for that is for most companies, but it's very important that layer 1 is on the tool surface. And what we're saying here is layer 1's on the IML, and that's problematic. I actually think that Craig has to fix this. I think it's fundamental composites that I must start with Z equals 0 on the tooling surface and the Z points the other way. There's no way around that, because if you flip Z, the hypersizer is going to assume that your stiffeners are on the wrong side like this instead of this. So you're in a whole world of hurt. So that's something I think that needs to be fixed. I think post-buckling, I think it needs all its own sheet. This is a complicated topic, and just clicking this on and then running your analysis thinking you're going to get the right answer it's kind of wild. But obviously what Hypersizer does is calculate an effective width of sheet, and it redistributes the loads to the stiffeners, which is good. But there's not a lot of explanation here. There's a lot I'd like to see of, hey, this was the load before and this was the load after, and this is what Hypersizer's done, and this is the effective width. I know some of that's in here, but I'd like to see that on the screen. I can't see it. So this is always, to me, a little bit of a black box. As you can see, the effective width is actually here. And then properties. This is really good. ABD matrix. All composites guys want to know what the ABD matrix is. This gives us the neutral axis. Of course, it needs to be from whatever reference plane you've used, so this can get quite complicated, because as you see in here, you can pick a different reference plane. And so whatever reference plane you pick in this options, when you come to look at this neutral axis, it's with respect to that reference plane. So you need to understand what this is relates to. These numbers here, again, I think thermal should be separate. Why not have a thermal tab? Hey, let's have a thermal tab. Let's have a thermal. Tell me what's going on with this thermal stuff. I want to separate it from my mechanical loads. Good stress engineers always separate your thermal loads from mechanical loads. You do not want to combine them automatically, then write a margin and not have any clue whether it's thermal that's driving the design and it can be complicated, because the thermal could be adding to the mechanical, it could be taking away. There's all kinds of things going on. So you need to understand the concept of my mechanical load is X and my thermal load is Y, and one is plus and one is minus. And so I'd like to see all of this stuff all go on a different sheet. This would make a lot of sense. I like a lot of this. This is all kind of good. Nothing wrong with this. Again, maybe it needs to be on a separate sheet called the stiffness sheet. I don't know. This is called the properties sheet. But I've talked to Craig about this many times, and he's spent a huge amount of investment. There's some very cool stuff in this Hypersizer, but what he's not done is made his interface keep up with the development of what he's done the last 10 years. I mean, from 10 years ago to where he is now, this is a whole different beast. It's got just a lot more times 10 capability and speed, and how we do the process. It's much more efficient. So I just think, well, I would love for him to invest in the interface. I think the interface is very important. It's what the user sees every day. This is like the sales pitch of, hey, this is my product. The sales pitch for here is, it's pretty good, but like I said in one of the early tutorials, it's like an electric car. Tesla, you open the hood and you go, man, I know there's a lot of stuff under here, but I open the hood and I can't see nothing, because the motor's hidden under the axle and the batteries are under the floor. So you open the hood and the trunk and you don't see anything. I really think Hypersizer's like that. I think it takes
users a long time, at least 6 months, maybe 12 months, to really get the hang of doing some fairly complex analysis, such as trying to optimize a wing box or something like that. It's very involved, and there's a lot of stuff to know, and we like to see the results on the screen instead of seeing them having to go look at the stress report and go and try and dig through all of the analysis reports. So I know maybe this sounds a little negative, but I just think it's a shame, because I think if only we could have a bit better interface, this tool would be just superb. It would just change things night and day. It would bring things out in the open instead of having to dig around under the hood all the time to try and find something. So I only want to review the project sizing form. There are a few other forms, which maybe I will review, but this is really where we do all of our work. So this is by far the most important form. We probably use this form 90% of the time, and the other form's 10%. So this is really where the development needs to be, is where the user's doing his daily work. And of course I will accept that these menus on the top here have become a lot better. I haven't gone into detail of those, because I wanted to stick to the basics. I could do a 2-hour discussion on all this stuff. I don't want it to get too detailed. There's a lot of good things that he's improved in the process, but pretty much all of the menus, this project sizing form compared to 10 years ago looks identical. It's not changed in a decade, with the exception of this top box, where we've got quite a bit more capability. And actually, one other comment is, when I choose, for instance, now I'm in composites, but let's just say that the computer's a bit slow because the video thing is working. But let's just say, well, I won't do it now, it's slow. Let's just say I pick a metallic material, and I'm only doing metallics. I think it's really important that I don't want to see all this composite stuff. I really don't, because it's just complicating the interface. You got this icon showing design. Well, that design isn't just for composites. I can go in here in this tooling tab, and wow, it's slow. I can go in this tooling tab and I can make the face sheets linked, so both of them are the same thickness. So Hypersizer says whatever the thickness of one is, the bottom skin needs to be the same thickness. I just click here and it's done. So nothing to do with composites. There's a lot of layup rules and things in there, but we're mixing up things, and I think that it complicates the matter. And I know it costs money, and it costs money. You're going to have two interfaces, which are quite a lot different, because composite's much more complex. But then if someone's working metals, he gets a much simpler interface, and hey, wowee, now it all looks a lot easier to use. So I do think we need to separate out composites from metallic structures. So for now, I think that's all I really want to say. I didn't talk much about this tab, but it's kind of just a miscellaneous bunch of stuff. Really all we're doing is collecting a bunch of variables. We use this for doing flatwise tension. Again, this to me should be a whole separate, this should just have its own, this adhesives thing should have its own analysis tab for sure. I think we have to come clean that some of these adhesive analysis in here is still really beta. I know Craig knows that. But for someone picking up the first time often I've seen a couple of guys come to me and say, hey, I want to do a lap joint. Hey, that's simple, isn't it? Just want to do a simple lap joint. Well, you know what? Hypersizer is going to really struggle with that. You can't do it. And so I go, wow, I'm surprised. I guess if anyone's out there that has done it and I'm wrong, I'll re-edit this. But as far as I know, it won't do that simple task, which is really the meat and potatoes of everything. Is we have a lot of lap joints. And then notes. I do think in this modern age that I do all this analysis, and I think it'd be good to have to keep some pictures in here of my free body and element numbers and everything, because it's very difficult to go look at this 6 months later and go, hey, what was component so and so, and if I could store some pictures in here or some summaries of my own, it would be good to keep all of the information in one place. I know that's really a secondary thing and not really that important, but it would be kind of a nice to have. Anyway, I rambled on for a little bit, probably because it's been one of my pet projects for at least the last 5 or 6 years. That I mean, my as a user, I don't want any more capabilities. Hypersizer is way more powerful than most other products out there already. I just would like the interface to come up to the standard of all of these features that we have in, and bring a lot of these features like section properties that we can do and the other interface. All that stuff could have its own interface and it could look really nice. So I appreciate you listening to me ramble on, but maybe some people agree with me or maybe they don't. So you can leave some comments, and thank you for your time. Thanks very much.